Good day. Welcome to this video. Now, in this video, we're going to open up a new module called the chemical process optimization. Okay, so this is the first chapter that opens the module. Um, so hopefully, we're going to enjoy the module for the whole semester. So without wasting any time, let us just go through the module. Now, the first topic or the first unit is called the chemical process optimization and control. Okay. And we are actually here for this unit number one. We're going to start with the introduction to process control and the instrumentation, okay, for chemical engineering students, okay, right. So now here we're going to learn more about what we mean when you talk about the process control, okay. The figure that we see over here, we have four diagrams, different four diagrams, and these different four diagrams, you can find them at different industries or different companies per se. So diagram number A, we have what we call the heat exchanger. Already we are familiar with what we call the heat exchanger, heat and mass transfer. Last semester, we've learned about heat exchanges. We know what it does. It actually allows the heat exchange between the two mediums, right? When you have the cold water and you have the hot water, there will be transfer of heat between the two mediums. We have learned deeper first semester about this. And then the second diagram, we have the jacketed chemical reactor. We can see that here we have the chemical reaction that is actually going to take place. Within this reactor, we have the reactants, and then definitely we're going to expect the products to leave out of this jacketed chemical reactor, and then we're going to have the coolant out and so forth. And then number C, we have the cracking furnace. The cracking furnace, we can see you have the crude oil being fed into the furnace, our organic compound, and this organic compound will interact with air, which deliberately going to react with oxygen. And therefore, we have the combustion reaction where we're going to have the loss of combustion products such as carbon dioxide and the useful product over here, which is a correct organic compound. For example, we know we use the diesel, the kerosene, all of those long or heavy organic compounds. We break them through this cracking furnace. Therefore, we get our digested organic compounds. And then again, lastly, we have the kidney dialysis unit. So in health field, they are quite familiar with this. When you have the human patient, probably the kidneys are failing the individual. So we know what are the functions of the kidney. We're going to have the impure blood into our operator over here, which will take the process through, and therefore the blood will now be purified, and then we'll go back to the human being, because we know that we need a proper purified blood, whether we have to get waste out of the blood uh, and all of those things. So we'll discuss these processes later on in this module, where we're going to discuss them a little bit deeper. Okay, but in this case, what we want to talk about out of these four processes, and they're continuous. Remember, we have different types of processes. We have the continuous, the semi-batched, the batched, and so forth. We'll deal about that division later on. So what I want you to understand on this slide is that when you talk about the control process, we are talking about what? There are four factors when you talk about a control process, okay? And I don't want you to confuse these. There is a control process and there is a process as it is. There is a process optimization. But in this case, what I want you to do is I want you to understand that when we talk about the process control, we're actually talking about the reducing of variability, okay? Here's the thing. We have the process that forms a certain product. For example, we take a reactant, we convert that reactant, and then we form a product. That's a process. But it's important to know how to control that process. So now how to control that process, we're going to look at reducing the variability. What do I mean when I say that in a process? what we supposed to know as chemical engineers is that when a process is taking place, there will be changes, right, during the process. So those changes, as chemical engineers, we try by all means to counteract those changes by reducing them. Because, for example, you want to form a certain product, right, from a certain process, but you have to understand that during the process continuation, there will be minor changes. So we're going to have to reduce those changes before we get our end product, right? So that's the reason why that's how we talk about the process control. And again, we need to maintain the specific measured conditions at desired level, which is true. Look, it is the same as you cooking chicken. Let me use this analogy so that you can understand why do we say we need to maintain the specific measured conditions at desired levels. When you take your chicken out of the refrigerator, it looks big. It looks like it can last you for 2 days, right? Before you cook it. But immediately when you put it in your pot and you cook it, what's going to happen? Your chicken now looks so small. And you start to ask yourself, why my chicken, like, this can last me even a day. I won't be able to eat this chicken for 2 days. So that analogy why I'm using it, because I want you to understand that as chemical engineers, to avoid things like that, we measure that the product that we want to produce in this reactor, it's this volume, this quantity. So we try by all means to maintain that specific measured product so that we can get the desired product. You understand? So if you didn't measure your chicken or you didn't control or try to maintain the chicken, therefore the chicken will be overcooked and therefore the meat will fall off and the chicken will look small because you didn't maintain, you didn't control that process of cooking the chicken. And then again, we're also going to refer to the product quality requirements to control the process, which is to, for you to get high quality product, what do you need to do in industry? You need to make sure that you control the process, because if you do not control the process, how are you going to get the top-notch product? It's going to be highly impossible, right? So it's very important to control the process. And then again, let's not leave outside the environment regulations. It's very important again to regulate the environment, because we know that more especially the chemical industries, we really pollute the environment with, for an example, number C, cracking furnace. We produce carbon dioxide during the combustion reaction. So this carbon dioxide, as it contributes to the atmosphere, therefore, that's going to lead to global warming, climate change, and all of those things. So as engineers, these are the most important factors that we need to take into consideration. So that's what we mean by the process control. So by the process control, we're not only controlling the process, but we also control how the process it is actually going by. We also maintain the machinery that are responsible for forming these products. Okay? So that's what we mean by process control. It's more concerned with reducing all of those things while maintaining the specific measured conditions at desired level, and while we producing the quality products and the environment conditions, the environment regulations. Now here we're going to talk about the process, right? We spoke about the process control, how to control that. Now we're going to talk about the process. The diagram that we see over here, it simply explains what does the process talks about in chemical engineering. Okay, chemical engineering, a process basically is when we take this feed, which is the reactants, right? We take our reactants into the process and we convert these reactants into a product. The moment when we produce the product, therefore, we know that our reactants has been converted in the process, it is done. But you need to understand within this parameter over here, which is the process, you need to understand that's where the chemical or the physical operations are taking place. So these chemical or physical operations are the ones that are actually going to convert our reactants into the products. So in chemical engineering, you need to understand that the process is often referred to as actual operation, which is this operation that we're looking at, for an example, or the equipment where the conversion occurs. So this is the equipment where the conversion occurs. So we refer to this as a process. Okay, so please make sure that you are able to distinguish between the process control and the process. The process control, it's all about reducing, it's all about maintaining, right? It's all about environmental regulations, it's all about all of those things that we have just mentioned on slide number 1. And the process is all about the conversion of the reactants into the products through the chemical reaction or through the chemical operations or through the physical operations. Now here we're going to talk about the importance of process control. Why is it important? You need to, like, we have the industries, right? We have the chemical industries, like the one that we see over here. This is a chemical industry. Now, in this chemical industry, we have the process control. Why do we need the process control? Because number one, we need a good process operation. Remember, a process control, it is there for reducing variability, right? For doing what? For producing the quality product and all of those things. So the process control, it is important because we use it to have a good process operation. This is a company. Company needs a profit. So in order for a company to be more profitable, therefore we're going to need a good process operation. But in which way are we going to have a good process operation? It's when we have the process control. We need to make sure that we control the process. Okay. And number 2, again, why is the process control important? Because we're going to talk about the process safety. When I say the process safety, I mean the whole machinery process. We need to make sure that as chemical engineers, the equipment, the process, everything, it is safe. Because if it is not safe, therefore it won't function properly. And then number 3, again, we're referring to the product quality. Why is process control essential? Why is process control important? Because it gives the product quality. We need a high quality of the product. So that's why we need the process control. That's why the process control is very important in chemical industry, right? And then number 2, minimization of the environmental impact, which is true. Like, for an example, we can see that here we are polluting the environment by producing these greenhouse gases into the atmosphere. Now, these greenhouse gases into the atmosphere, they will most definitely damage our ozone layer, lead to global warming, climate change, and all of those things. So we need, as chemical engineers, we need to make sure that the process control, it is there, because it will help us to minimize environmental impact. It will help us to minimize the environmental impact. Okay, so this is also very important. Now here, these are the general process here are the importance of chemical process control, right? In general, process control is used to. So what do we use the process control for? Remember, these are the importance. Why is it important to have the process control? This benefits the company, benefits the environment, right? But here, why do we perform the process control? Why do we need the process control? What is the process control used for? Why? Right? These are the importance, why we need it. Why do we use the process control? The first reason is that we need to suppress the influence of these external disturbances. We are industry, right? When you talk about for an example, when you talk about the external disturbances, maybe we can talk about the climate changes. We can talk about the climate, all of those things. So basically, we want to counteract any disturbances that will take place, because any disturbances that takes place will hinder the chemical industry to produce a product. So the process control, it is used to suppress the influence of the external disturbances, because we don't want those disturbances. We don't want those counteractions. So what do? We use the process control. And then number two, why do we need the process control? It's because we want to ensure the stability of the chemical process. For a process to be completely done, meaning we want to achieve all of these four things over here. So that means we need to ensure, even to suppress, to maintain those things. Bulletin number two, we need to ensure the stability of chemical process. Because if we're not ensuring the stability, how are we going to give the importance of process control? It's going to be impossible. We won't be able to have good process operation. We won't be able to have the process safety. We won't be able to have quality product. So that's why we need to ensure the stability of the chemical process, that it is stable. And then again, we need, what is the process control used for? It's used to optimize the performance of the chemical process again, not only the stability, also to optimize. To optimize basically is to regulate so that it can work at the optimal conditions. It can work at the normal conditions. So that's what we mean. Because it doesn't work in optimal conditions, it's either it's not gonna do its work, or it's gonna not perform, like literally it won't perform at all. Okay, so we need to optimize the performance of the chemical process. So what we see over here is a basic process control systems, right? Remember here we're talking about the control, right? We have the set point, we have the control. Basically here we have the controller and then the set point where everything starts to move inside, right? So this is a controller. So how to control the process before the process can take place or it can go by, we need to make sure that we control. So in this case, we're going to have the set point, and then there is our feed going into the process, right? There is our controller, and then here we have the actuator, right? And then here we have the controller signal. This is the controller signal through the actuator. And then therefore, this is where the feed is going to go. Before we get our reactants into the process, we need to control them. We need to actuate them. Therefore, they go through into the process, and therefore the inputs, we know we're going to have the disturbances. We're going to have the manipulated variables, right? Because it's nature. And even if it's not nature, but as chemical engineers, we need to counteract for such things, right? Therefore, here we're going to have the outputs, which is our the product, and then we do the measurement of our product to see if the product that we get, it is the desired one, right? So if the measurement is not, therefore we take back our product into the controller, and then it gets controlled, actuator, and then the process, and then we have the disturbances, so forth, output, measurement, and so forth. So basically, that's how we go about for this session.